In this video, we're going to take a look at polygons, and we're going to look at solving for one angle inside of polygons. So before we do that, let's review. We've got two formulas so far. We're going to learn about two more today. And the two we've seen so far is the sum, the interior and exterior sum. So if I'm looking for the number of degrees inside a polygon, on the inside it would be the number of sides minus 2 times 180, and exterior is always summing up to 360. So let's take a look at a problem like this. What if I want to solve for one angle on the outside of a polygon? Okay, well, what I'm going to do here, let me find my pen, that's the first thing I'm going to do. All right, there we go. I got to think about what is the sum of the angles. Well, I know that all of these angles add up to 360 degrees because these are my exterior angles, right? So I've got 360 degrees. And what I'm going to do is I'm going to subtract out 95, I'm going to subtract out 80, I'm going to subtract out 62, okay? So let's go ahead and do that. 360 minus 95 minus 80 minus 62, and I get 123. Now let's double check to make sure that makes sense within our picture. It doesn't always have to match the picture, but in this case it does. 123 degrees does seem reasonable for that angle. So if I'm looking for just one angle, I can subtract out the other angles to solve for that, because I know each of them, all of them together add up to 360. Now let's do a similar thing with the interior angles. So I'm looking for one interior angle. So just like before, I need to figure out what the sum of the angles is. So I look, I've got 1, 2, 3, 4, 5 sides, right? 5 sides. So I'm going to do 5 minus 2 times 180. I'm just doing that, the interior formula, right? Interior sum formula. Sorry, there we go. 5 minus 2 times 180. If I multiply that out, I get 540. Okay, now 540 is the number that I know these angles add up to. So one way I could express this is as I could add up 91, 80, 100, 160, and x, add them all up and set them equal to 540. The other option is just to do what we did last time. Once again, we're going to take all of these angles. We're just going to subtract them out. Okay, subtracting out each one of these, okay, from 540. So let's go ahead and do that and see what we get. 540 minus 160 minus 100 minus 80 minus 91. All right, and that gets me 109 degrees as a final answer. All right, so far we've just looked at solving for angles, given the fact that we have all the other angles inside our polygon. We also need to talk about a different type of polygon. So we've just talked about convex and concaves. Now there is a subset, a type of polygon, or a class of polygons that is like maybe a little bit extra. It's called regular polygons. The polygons are regular if they have all equal sides and all equal angles. So in this case, if all of these sides were equal and all the angles were equal, this polygon would be a regular polygon. Now, if I have a regular polygon, the number of the angles are going to be a fixed number. So like for this hexagon, if all the angles are equal, and for every hexagon that has all equal sides and all equal angles, those angles, the one angle is going to be the same for all of them, right? So if I'm looking for one angle inside a regular polygon, so I have that hexagon and I know all of these are equal, we have a formula for that. Now let's talk about where this formula comes from. Notice here on the top, n minus 2 times 180. That's the formula for the sum, right? And all we do is we say, okay, so what's the sum of the angles? So let's do that here, 6 minus 2 times 180. And that ends up being, I should have this memorized, but I don't. That comes out to 720, okay? Now, that's the sum of all of them. Now, if I know all 6 are the same size, how would I check to see what one of those angles would be? Well, what I'm going to do is I'm going to divide by the numbers of angles I have. How many angles do I have? Well, the same as the number of sides. So I'm going to say 720 divided by 6, or n minus 2 times 180, that's the sum, divided by your number of sides. So that's where this formula comes from. Okay, it's not just kind of made up. It's actually coming from two pieces, the sum and the number of angles that we have. So if I plug 6 into this equation, I end up with something like 1 carry 2, let's just divide that by 6, and we get 120 as a final answer. All right? So hopefully that's making a little bit of sense here. All right, So let's do another one here. Solve the Pentagon. We know the Pentagon is regular, equal sides, equal angles, solve for x. So we're going to do 5 minus 2 times 180 all over 5. All right? And let's just go ahead and see what that comes out to be. 5 minus 2 is 3 times 180 divided by 5, and I get 108 degrees. All right, so hopefully this is making a little bit of sense. Now, we can do the same thing for the exterior angles. Oh, we've got one more, sorry. Find one interior angle of a regular dodecagon. Remember dodecagon, that would be 12. So we would set this up, and I'll just set this one up. We won't actually solve it. 12 minus 2 times 180. We'll divide it by 12. And if you're not getting the right answer when you plug it in, do make sure that you keep those parentheses when you plug it into your calculator, or you will get the wrong answer. All right, now let's take a look at our exterior angles. So just like our interior angles, we're going to take the exterior sum, which is 360, we're going to divide it by n, and that's going to solve for one exterior angle. Now this only works for regular polygons. You cannot do this for any polygon you want. You can only do it for regular polygons. If you see regular, that should be a big tip-off that you're going to use one of these formulas over n. So 360 over n. So in this case, my n would be 6, so I would have 360 over 6, and I would get 120. Now, hopefully, I'm sorry, not 120, we would get 60. Let me back that up. 360 divided by 6 is equal to 60. All right, now, if you remember back to when we did this for the hexagon before, remember the one interior angle was 120 degrees. So one thing to note here is that the interior angles and the exterior angles do add up to 180. Okay, that's true for regular and non-regular polygons. So you do have a relationship between the interior and exterior angles at every angle, but the same here. That's just something that you should probably notice as we go about, and will be helpful down the road when we solve some problems. All right, let's find one exterior angle of a regular nonagon. Nonagon has 9 sides, so we're just going to do 360. We're going to divide it by 9, and I don't know why I wrote 390. I'm sorry about that, guys. 360 divided by 9, and I get 40. All right, so that wraps up everything that we're going to cover in this lesson. What I do want to show you just before we finish here is a helpful chart. This is a chart that I teach all my students to use that helps us keep track of our polygon formulas. Now let me show you what I mean. So we know the interior sum is n minus 2. Sorry, let's try this again. N minus 2 times 180, right? That's the sum. And how do I find one angle if it's regular? Well, I do n minus 2 times 180, and then, here, let's do this. We'll underline it as a fraction bar, and we put it all over n. Okay? So notice, these two are almost the identical formulas, just one is over n. Now, what's the sum of the exterior? Well, it's 360. Okay? And then what is the exterior one is 360, and once again, underline it and put it over n. All right, so notice these are the 4 formulas you need for your polygons. And please do notice the similarities between the formulas. It will help you remember them. If you can remember the top 2, the bottom 2 you just divide by n. Also, this chart is helpful to have in your notes, especially when we start doing some mixed review. It's good to say, well, are they asking for one angle or all the angles? Is it regular or not regular? If it's regular, we're going to be down here. If it's not regular, we got to stay at the top here. So hopefully this is helpful to you, but this wraps up this lesson on solving for one angle in polygons.